Hello friends, welcome to my math tutorial number 46, dated 5th July 2025. My name is Mr. Lovex Zere Rorengo. Today's topic is reciprocals, a Form 2 topic which is set mostly in paper 1, section 1. Apart from being set as a solo topic, sometimes it is set in combination with the table of square roots and squares, cube and cube roots. In such a case, a student is required to use a combination of tables to evaluate the expression given. In this section, I'm going to handle reciprocals and the application. Welcome. If A is a reciprocal of B, then A times B equals to 1. That means that if I divide both sides by B here, I get that A equals to 1 over B. Therefore, if B is the reciprocal of A, then it means A equals to 1 over B. Also, if A is the reciprocal of B, it means that B equals to 1 over A. A number multiplied by this reciprocal is equal to 1. For example, the reciprocal of 2 is a half. The reciprocal of 2 over 3 is 1 over 2 over 3, which is 3 over 2. The reciprocal of 1 and 2 over 5 is 1 over 1 and 2 over 5, which is 5 over 7. The reciprocal of 0.4 is 1 over 0.4, which is 10 over 4, which is 2 and a half, which is 2.5. The reciprocal from tables. Express the number in standard form, such as A times n, 10 power n. Then read the reciprocal of A from the reciprocal table and multiply the answer by 10 raised to negative n. We mean that when you are using tables of reciprocals, you express the number in standard form, then read the reciprocal of the number A from the reciprocal tables, then multiply the answer you get by 10 raised to n. It means you change the sign of the power of 10. Example 1. Example 1. Read the reciprocal of each of the following numbers from tables: 0.4, 2 and 7 over 8, 8,789, 0.015625. Solution. For 0.4, we express that number as a standard form. That is, it is reciprocal will be 1 over 4.0 times 10 power negative 1. That means that from the table, the reciprocal of 4.0 is 0.2500. Then we change the sign of the power of 10 to comes times 10 power positive 1. Therefore, that means the answer is 2.500. That has been obtained from the previous section. Then 2 and 7 over 8 is expressed as a decimal, because in tables we have numbers which are in decimals only. Therefore, it is reciprocal of 1 over 2.875 times 10 power 0, because you have not moved that decimal place. Therefore, the answer will be 0.3478 times 10 power 0. This is the reciprocal of this number from the table. The number remains 0.03478. For 8,789, we write 1 over 8.789 times 10 power 3. From tables, the reciprocal of 8.789 is 0.1138 times 10 power negative 3. We change the sign of the power of 10. That one means now the answer becomes 0.000138. Part D, for 0.015625, we have 1 over 1.5625 times 10 power negative 2. We have written this number in standard form. Therefore, from tables, the reciprocal, we cannot read the reciprocal of this entire number, which has 5 digits. We have to cut it down to 4 digits. Therefore, we round off these 2 by 5, which is more than half. Now to change this one to be 3. So that from the table, we read the reciprocal of 1.563 times 10 power negative 3. Now from tables, the reciprocal of 1.563 is 0.6397 times 10 power positive 2. We change the sign of the power of 10. The answer becomes 63.97. All these answers can be proven to be correct by use of a calculator. But when instruction are given to use a table, a calculator should not be used. Let's move to application of reciprocals to numerical expressions. Example 2. Use reciprocal tables to evaluate each of the following expressions. Part A, 4 all over 0.025. Part B, 8.1 all over 0.375 minus 7.5 all over 37.5. Now, even before we continue the table, you can use a calculator, you get the answer, but don't write it. You just write it somewhere, then you can counter check. When you have used the table, you can confirm that the answer is valid. Now, for part C, we have 5 over 0.0396 plus 12 over 0.593. Solution, we start from part A. For part A, 4 over 0.25, that's the same as 4 times 1 all over 2.5 times 10 power negative 2. When we are using reciprocals to work out numeric expressions, we apply the concept of use of reciprocal tables to the denominator. The denominator remains the way it is. We multiply the denominator times the reciprocal of the reciprocal of 1 all over the denominator. Therefore, we apply a table of reciprocals to find the reciprocal of 2.5 here, which is 0.4000 times 10 power 2. Then when we work out the bracket, we get 40.00 times 4. That gives us 160.00. Part B, 8.1 all over 0.375 minus 7.5 all over 37.5. For this case, we work out each part as we have done part A. The first part is 8.1 into 1 all over 3.75 times 10 power negative 1. The second part is 7.5 times 1 all over 3.75 times 10 power positive 1. Now, from reciprocal tables, this number and this number are the same. The reciprocal is 0.2667. Now, for the first case, 8.1 times 0.2667 times 10 power 1 minus 7.5 times 0.2667 times 10 power negative 1. The powers of 10 change in each case. Then the bracket gives us 2.667 times 8.1. The second bracket gives us 0.02667 times 7.5. Finally, using a calculator, the answer becomes 21.402675. The answer should be written as it is in full, unless rubrics or instructions are given in which condition the answer should be left at. Part C, we now do it the same way we have done part B. For this part, we have 5 into 1 all over 3.96 times 10 power negative 2. For the second part, we have 12 into 1 all over 5.93 times 10 power negative 1. From tables, the reciprocal of 3.96 is 0.2525 times 10 power positive 2. And for 5.93 is 0.1686 times 10 power positive 1. Working out the expression in the brackets, we have 25.25 times 5. For the second case, we're having 1.686 times 12. Finally, we get 146.482. Let's move on to application of squares, square roots, cubes, cube roots, and reciprocals all together in one single expressions. Example 3. Use tables of square, root, square, and reciprocals to evaluate. In most cases, when a question is set which requires use of more than one kind of table, the question itself mentions the kind of table which are going to be used, and sometimes in that orderly manner or in the order in which they are going to be used. For example, this question, the question says use tables of square roots. Here it means we are going to start with the square root. Square, then we are going to have the square and the reciprocals to evaluate. The expression is 1 all over square root of 4.296 plus 1 all over 1.872 squared. Solution. We start from square root. The square root of 4.296 times 10 power 0 equals to 2.0726 times 10 power 0, which remains 2.0726. For the square of 1.872, we have 1.872 times 10 power 0 squared, which is 3.054 times 10 power 0, which is 3.504. These values are read from the tables. Then we now, after working out the square root and the square, we now have this expression 1 over this number plus 1 over this number. Now we now apply reciprocals as in the previous examples. Now for this case we have 1 times 0.4824 times 10 power 0 plus 1 times 0.2854. Adding the two parts we get 0.7678. Example 4. Use tables of reciprocals and squares to evaluate. For this case, we are going to use this reciprocal and the square to evaluate. For the reciprocal part, we have 1 over 2.456 times 10 power 1. From reciprocal tables, we have 0.4072 times 10 power negative 1, which gives us 0.04072. From tables of squares, 4.346 squared equals to 18.888. Now, we add the two parts of the expression, we get 0.04072 plus 18.888. The final answer becomes 18.92872. Example 5. Using square roots, reciprocal and square tables, evaluate the following correct to false significant figures. In this case, we have an instruction. Correct to false significant figures is an instruction or is a rubric that we must give our answer in. Now here we are, when we have a power of a half, that's like a square root, and here we are having a square, and here we are having a reciprocal. Now let's start from the square root part. From the square root part, we take the square root of this number, that is 6.458 times 10 power negative 2. Now for that case, we get from the table, the square of this number is 2.5413 times 10 power negative 1. We divide the power of 10 by 2, we get negative 1. That gives us 0.25413. That's for the part of the square root. For the second part, we start from the reciprocal first before we go for the square. From the reciprocal, we say this 2 times 1 over 4.327 times 10 power negative 1. From reciprocal tables, we get this one to be 0.2311 times 10 power positive 1. That is 2.311 times 2. The answer is 4.622. Now, we have obtained the reciprocal from the second part. After the reciprocal, we move on to the square. We square that number. Now, the square of this number from tables is 21.363. Now, finally, we combine the two parts of the expression, the answer from the square root side and the answer from the reciprocal and the square side. We add the two to get a sum of 21.61713. But we were asked to give our answer correct to false significant figures. Therefore, we come here and say this is 1, 2, 3, 4. 7 is enough to change this one. Therefore, the answer is 21.62. Correct to false significant figures. Example 6. Express 3136 and 2744 as products of their prime factors. Hence, evaluate the square root of 3136 or over the cube root of 2744. Solution. We factorize this number 3136 as 2 times 1568 all the way to 2 power 6 times 7 power 2. For 2744, we factorize it down to 2 power 3 times 7 power 3. Now the expression that we were given here becomes the square root of 2 power 6 times 7 power 2 all over the cube root of 2 power 3 times 7 power 3. For squares, we divide the powers by 2. For cube roots, for the square root, we divide the power by 2. For the cube root, we divide the powers by 3. That one becomes 2 power 6 becomes 2 power 3, 7 power 2 becomes 7 power 1, 2 power 3 becomes 2 power 1, 7 power 3 becomes 7 power 1. That we are having 2 power 3 times 7 power 1 or over 2 times 7 power 1. Now this 7 power 1 and 7 power 1 cancel. We remain with 2 power 3 or over 2 power 1, which is 2 power 2 or 2 squared. The answer becomes 4. For practice purposes, I like you to pause the video or screenshot and get these questions, work on them. In case of a challenge, get back to me, we share. The questions are here. The first question is find the reciprocal of 0.324, correct to four signal figures, and hence evaluate the cube root of 0.512 or over 0.324. Part 2, using tables of reciprocals and squares, evaluate 1 over 0.3654 minus 4.151 squared. Question 3, use square roots tables and reciprocal tables to evaluate 10 over the square root of 0.625 plus 4 over the square root of 164. Question 4, use tables of reciprocals and square roots to evaluate 0.1 over 0.0351 plus the square root of 0.498. Question 5, use tables of reciprocal squares and square roots to evaluate the square root of 1 over 0.2365 plus 2 over 2.6228 squared. Question 6, use tables of reciprocals and cubes to evaluate 1 over 34.52 plus the cube root of 0.787 plus 0.934 cubed. Question 7, which is the last one, use tables of square roots, reciprocals and squares to evaluate 1 over the square root of 0.7235 squared minus 1 over 10.56. Thank you for watching. Thank you for listening to me. I appreciate your time and sacrifice. Welcome in advance to my math tutorial number 47, which is going to talk about indices and logarithms.